Hi, hello, we are online. Hello, my dear friends. Yeah, I'm double checking that I'm not on mute as last time. It was embarrassing. Yes, everything is fine. After a long week, we are back at the project or on the project of the STM32MP215. Yeah, it's a ongoing project, currently in part 12, but I don't know how long it will take. But I don't know if it matters. But I have an update for you, and I wasn't sure if I wouldn't do a intermezzo part instead of STM32MP215, a part about the Raspberry Pi CM4 Compute Module 4S, like SODIMM format. Please let me show you something. I received the assembled PCBA by Eisler. The quality is phenomenal. It took a while before I get to that project back because of that ongoing work for other customers. Obviously, this isn't paid project, so some other project must have a higher priority, and they have. So a small update. I don't know if you could see, because the camera. I will try to focus on that board. Yeah, you could see it's my alternative PC byte plate, but yeah, can you see it? Yeah, now I think it's in focus. So, most important thing, this is the prototype version, version 01 or first version. It works. There was one small mistake. The VBAT, like the voltage from the battery, I used the CR2032 slot because in the datasheet there wasn't mentioned the parameters of the battery. So I thought it's like a battery for like the backup or the deep sleep mode. I don't know. I didn't know, but I was wrong. This battery must be a power source that the entire CM4 can run from it. I'm not pretty sure. I'm not sure. The original reference design for the older CM Compute Module 4S SOD modules, the 3 designed for version 3 but compatible with version 4 as well, connects this VBAT to 5 volt directly to the input voltage source. And I missed that detail, and I connected it to the slot. And the Compute Module 4 doesn't run when the battery is only the cell, or even without the battery, like it doesn't run. I don't know why. The power supply somehow, or not the power supply. The behavior I observed and I measured, and I will be publishing in a few days, is completely different from the behavior I observed. So the module didn't run. The module was cycling the run signal, which means that the module was in a reset, cycling the reset state and the run state, or the local power supply on the compute module didn't run, and it initiates the boot sequence again. And the period of the signal was about, let me show you here. This is the 3 points. The yellow is 3.3. The blue is basically 1.8 signal of the disable eMMC or the other one, yeah, like marking that the CPU wants to boot from the external memory or from the eMMC or from the boot source, and the purple, the magenta, is the run signal. And you can see that every about 5 milliseconds the CPU was in a reset, like, I don't know, it was cycling the function between reset and run. When the CPU, when the run is low, it's in reset, so it was running, then fall back to reset, and slowly back to running and reset. I don't know. Yeah, it's like an analog signal, but still, it didn't run. Once I connected the VBAT to 5 volts, it was like, yeah, you can see low before the power up, then a short cycling to not to reset, to, yeah, some initiation or starting sequence, and then constant high. It means the CPU was running and able to boot, etc. So it was small circuit mistake number 1 and small PCB layout / component issue number 2. I can see that the mounting holes for the SOD module are slightly off. This is easy to correct, and these mounting holes are not necessary or crucial necessary for the first version, so I even didn't know this before now. But the SODIMM slot, as you can see again here, the, yeah, camera, please focus. Like, yeah, now, like the SODIMM slot, and I saw that there is only one, like 200 pins SODIMM with the same dimension, the same pad page, etc. But I was wrong, and the same key. It's key E-key module, E-key version, and I thought it's only one version. And in the face of ordering the PCB assembly, I chose one of the SODIMMs that was available, but I was wrong. There are 2 versions. There is like standard version SODIMM for DDR memories and standard version for DDR2 memories. And I didn't know that the E slot was like 0.9 millimeter off. So the soldered slot is incompatible with the SOD module. How did I correct it? Yeah, I took my pair of cutters and I removed the E key from the slot. So yeah, this SODIMM slot has the same PCB footprint, but the E key is the slot, the key is 0.9 millimeter. Should be 0.9 to the left, and it was too far to the right. So yeah, so I solved both issues. The module runs perfectly. I played with the GPIO outputs yesterday when I tested it. The LAN controller works well, so I updated the system. Both USB A's work well. Yeah, and yeah. And the third mistake was that the USB-C for the power supply here is too close to the HDMI. So in the second version, I worked on yesterday as well. I had to move the USB-C about 1.5 millimeter to the right to make more space for HDMI along with the USB-C. It's an evaluation design, so it's not intended to be used as is. It's like for your purpose. When it's released, you can reuse, you can modify, you can do with it everything. It's like my reference design for this platform. So the good news overall is it works well. I will be publishing a few short videos about the unboxing, the PCB, how it looks, and more videos are to be published. And let's get back to this STM32MP215, which scares me a lot every time I think about it. I don't know why, but this project is not as easy as it looks to be at the beginning. But it's the hardware design, and I'm pretty happy that I have a lot of time on it for it. So last week we worked on the schematic review using BV circuits. We were successful with identification of all possible bottlenecks of the design, or parts where can be some possible mistakes. So today we can start with the component layout or something like this. So I will switch the schematic to the PCB, and I will work on the initial version of the PCB layout, consisting of the MPU, the DDR memory, and other components, which is like a core of this design, the MPU and the memory. And then obviously the PMIC, the power blocks, then Ethernet, probably M2, but it will be a job for a few hours. So today I will start with it, and then I will continue next week, maybe offline a few hours. I don't know. I would like you to see everything and to be recorded, and in the streams to be recorded everything. So probably I will wait until the next stream. But the issue is that once a week, one session of 2 hours is too short, and the gaps between sessions are too long. So I constantly forget the small things regarding the design. But I'm talking too much, and I should work more. So let's get back to PCB layout. Yeah. I had to filter my coffee for this session because to me it's a difficult time because I'm not so talkative normally. So I push myself to this. You'll probably understand. So PCB layout. Let's open the PCB editor. Currently, I am in version 10.0.3, which is full of bugs. It crashes multiple times today. I'm checking. Yeah, it's still the last released version, the latest released version. So full of bugs and full of things that don't work, but it is what it is. So I'm checking comments, no comments yet, so okay. So F8, update PCB from schematic, no errors at the moment. Now, still no errors, no warnings. Okay, so we have a lot of components here, as you can see. Like a lot. So first things first. I have to say hello to my followers. Where is your hat? Here. Say hello. Bye. switch off the front cell screen to make some room and switch off or disable the values. Yes, now the component group is more airy, and let's, yeah, and visibly and obviously or not, yeah, you can see the blocks. Here is the Ethernet, here is the M2 block, here is the HDMI block with some big, no, it's not HDMI, it's USB. Yes, it's the, sorry, it's the USB with, yeah, these big caps. Yes, yes, it is. Here is the SD card block. Here is the peripherals. The SW1 is the dip switch for the boot modes. Here is the DDR2, no, DDR2, DDR3, yes, DDR3. This is the PMIC, so should be somewhere near the power entry USB. This is, what is this? This is the power block, yes, and this is the MPU. No, this is the MPU power. Yeah, yeah. It depends how we take it, because it's the MPU block entire. Both of these blocks are MPU. Okay, so as I said, I want to start with the core, which is DDR memory and the MPU. And what's the better source than the reference? Design, and I want to open the component layout sheet, which is, I think, at the end of the data sheet. Basically, we have two options. I can copy the image, or I can open the imported PCB layout, which is here. Yes, but I think the component layout from the datasheet will be better, because it's not so complex. So this is the top view, and this is the bottom view, but yeah, the flipped bottom view. Okay, so I will copy just as is. No, I will copy the exact shape, and then I will find the dimension of the board. So it's a component layout top, and I will do the same with the bottom side, because it's better. It's easier to do it at the same time, because finally we will need it soon or later, and it's more effective to do it now. And it's bottom. Okay, and now the dimension of the board. Hi Robert, how are you? Thank you for being here, if you are still here. The board dimension is maybe still in the... No, not here. Oh, probably this is better with the... No, I think it's good with the dimensions. So the dimensions can be taken from the Gerbers. Still no dimensions here. Here is the here is probably the impedance controlled parameters. PCB material, but not dimensions. Yeah. So I have to open the Gerber file. Mechanical, maybe here. Locked. PDF, CD PDF, okay. So probably it will need Adobe Acrobat. It's been disabled. Enable this feature. Options. Trust this document. I'm okay. I'm not so patient. Acrobat crashed. No, nobody is perfect. So open Gerbers, which are where's in the docs here. No, it's Altium. Manufacturing. Gerber. Okay. I don't know in what layer the board edge is placed, so I'm going to open all of them. Okay, so probably, yeah. So this should be in the millimeters. So I'm pressing space to zero the local scale, and then I have to read the dimensions here. Let me write it down because my memory when I'm speaking is limited. So 104 times 73.5. Yes, this is our dimension. So in the PCB editor, we can import the image. Here is the project, picks and top. Place it here, and I think the new feature in this version of KiCad version 10 is that you can define not the size of the image by scale, but you can enter the physical dimensions here, which is very convenient. So 73.5 makes, yeah, I will use this 1.4 because I'm somehow at the edge of the accuracy. But yeah, so this is the actual size of the PCB. We will verify it in a second. So I am making it more like transparent. You can disable it anytime, and you can lock it, because when I will be moving the components and I accidentally click on the image, it will be selected, so it's not very convenient. So I'm pressing L to lock it. Now it's locked, and you can see here, no, you can't see here. I have to switch my face off. I will keep it like disabled and start placing the big components. So here is the BGA. Here is the pin number 1, as you can see here, and I will not try to reinvent the wheel here. And I will believe that the engineers of the board did a good job. So I will try to place the components at the similar spots, because yeah, even the M2 connector probably, yeah, it can save a lot of time, and the board is not so big. So what I can do is to try to shrink the size of the board under 100 millimeters, because it's less expensive to source the boards, or to buy the board, to purchase the board with the dimension lower than 100 millimeters. So as you can see, all the pads are placed on the pads, so the dimension works and the layout works, the PCB footprint is correct. Now the DDR memory, yeah, the big change number 1, the original design uses DDR4, which are as a family, as a commodity, unavailable these days because of the AI computers, etc. And I had to use the DDR3 memory. But we will see. Yeah, I will place it at a similar spot, or on the similar spot, and we will see. So this is the rest of the memory components, and here is the rest of the CPU or MPU components. Now we have the bottom side component image, which is here. And I will try to place it exactly here. Yeah, this will be better. Now that's over, and I want to switch in between these images, and the best way is to assign it to one of the layers. So the associated layer with the bottom view will be user 2 layer. So I'm assigning it to the user 2 layer, and as you can see, when I switch off the layer, the image goes off, and the same will be done with the yeah, and locked as well. So now it's locked, and this image is now connected with the copper layer, which is not optimal, and I'm assigning it to the user 1. Okay, and if I, yeah, now it's bottom, now it's top. It's not it's not so difficult, but as I can see the here is it's a flip view, and I can't mirror it. Yes, I can't mirror it. So when I want to see the bottom side, I need to switch the flipboard view here. No, it's flipped along with the image. So yeah, that's an issue. So I have to mirror enable override locks where in the previous versions the context dialog window appeared and I can override locks in there, and now it doesn't work. Enable override locks. Okay, so some, I don't know. PCB editor, override locks, yeah. The best way is to I don't know where it is. Oh. I'm looking for the override locks option. I don't know where it is. Hello, yes, I'm working on the STM32MP215 board, like adopting the reference design with it. And now we are at a state that the PCB, yeah, I'm starting working on the PCB. The schematic is finished. You can see all the streams on YouTube or on my LinkedIn. Now I want to yes. Where in the KiCad 10 is the override? How it's called? Override locks option. Update from schematic. Check the override locks checkbox. Okay, and obviously in the schematic editor for design blocks. I think this video is it's version 9, so it changed. I don't know where is the override lock. Enable override logs to operate them. Where is the... Oh, here is the checkbox. Okay. Okay, so I can... here. Override logs. Okay. So get back to Gerber's and no Gerber's datasheet. I have to flip it here. No, I can't mirror the... Okay, I have to open the picture. Complications. Here, in the preview, and tools, and here is flip horizontal. Yes. Save. Okay, and now import it again. Button 104. Here. No, and this corner goes here. Yes, it's locked, but I have to assign it to option the user 2 now, uncheck the locked items, and then I can disable it. So when I... Yes, this is it. This is it, and when I switch the report view, it mirrors the image as well. Fine, it works. Okay, so what else? As you can see, the reference designations are difficult to read. Here is maybe better. Yeah, this picture is better. Okay, so again, maybe even this one. Okay. So again. So this is top. This is bottom. So I have to do it again. So I'll start with the bottom because now it's missing. I again forget to assign it to the layer user 2. Fine. Now I will delete. What's this? Yeah, I'm in the flipboard view. Okay. Okay, it seems that the KiCad somehow reload the, yes, it reloads the image automatically. Okay, so probably it's enough to enable. I'm too slow. Yeah, components from the top are here. So we need, yeah, I forgot to mirror the bottom image. Oh, flip horizontal, save. No, it must be done again. How many times I will do it again? Now I don't need to assign it because I'm already in user 2. I did it to avoid the repeating steps because I'm obviously making mistakes. Okay. Okay, so I will try to go. Okay. I don't know what I'm doing. Frankly, I don't know what I'm doing. I don't know what I'm doing. I want to place the components the way that it will take the least amount of time. But I don't know how. I don't know how. These components are VDD. So when I go here and pack it, it's VDD components. These decoupling caps are VDDQ. VDDQ. We have 1, 2, 3. Okay, it's 5, 9, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so each pad needs a decoupling cap. I don't know why. How to decide where will go the bigger caps and where to the lower ones, the smaller ones. But yeah, obviously not here. They place the bigger one. Yeah, 2 at the bottom and 2 at the top. How many components is at the bottom? The PMIC. No, it's not PMIC. U18. I don't know what's U18 because this PDF is not. Yeah, it is. It's LCD. Okay, so we don't need it. U23. What I'm trying to say that it's the bug for the 3.3. Okay, here are some small components. Yeah, the decoupling caps at the bottom. D2 is what? Some big diode. D2 is, yeah, the battery and the VDD IO for the power. Yeah, so all the power blocks. U21 is the voltage translators for the M2. Yes, and nothing more. So I want to say that the display will be removed, the M2 connector will be here, SD card will be there, the camera connector will be removed or won't be there. This is the power entry block. Here is a lot of space here, but it's below the M2 connector, but the M2 connector can be moved upwards to make some room for the power supply block. What I want to say is that the original design is 4-layer. It's not very optimal, and as you can see, where we checked the JLC PCB quotation for the boards 10 times 10, 100 by times 100 in 6 layers, with the high quality finish of ANIC, it's the default option. 1.6 green, it's the widest manufacturing profile. So the 5 boards are $48, which is not cheap, but it's not crazy expensive. When I go to 4-layer, it's more than half. So it means that, no, even with ANIC, yeah, if I go with the 4-layer, 100 times 100, 4 layers, it's $44. I think the price goes higher. Yeah, it's yeah, the via covering state from the precision. Yes, epoxy filled and capped. Okay, okay. Why is so crazy expensive now? I don't know. Again. Yes, now. Material, ANIC, gold, 1U, capped, okay, via hole size, okay. Okay, okay. So it means that I would rather use 6-layer PCB with the bigger dimensions than the smaller one with the bottom side components. There are decoupling caps beneath the MPU, which probably will be unavoidable, but it's much easier to solder a few components on one spot than multiple components. But yeah, if I will place or solder the components still on the bottom, it doesn't matter if there are 100 or only 10 components. So yeah, I don't know. I don't know. As I said, as I can see, I don't know what I'm doing, and I am, yeah, trying to navigate. Yeah, it's not easy. So N1 is the first one, N1. These components are VDD. The other one will be on the bottom side. So I will, yes, I will keep it here. So the first small N1 is the first pad, N1. N1 is here. Probably this one. B2. B2 is here. Maybe this one. D9. D9 is here. Probably this one. G7. G7 is here. Can be this one. Yeah, my cartridges for the components are more like wider or higher in size. So K2, yeah, it is K2. K2 is here, so this can be this one. I don't know, maybe. K8. K8. And 9. Okay. It's probably not correct, but yeah, we will adapt. So again, the bigger ones. This is the top one. Goes to, I don't know where. Probably this one. So can be the H2. I don't know. The other one will go to the top, to the bottom. Yes. So this one will be A1, near the A1. C1 is here. Probably it will go down. Here is not. Okay, I will place all of them near their pads. A8. C1. Do you want the music or not? I switch it off because it pissed me off, but maybe something different. I set C1. Yeah, it can be C1. It's pretty close. Yeah. I don't know. I will create the second row and we will see. C9, C1, C9. Yeah. Obviously, these decoupling caps won't be placed in the two rows, but I'm working on it in the meaning that the components that are closer to their pads will be placed on probably on the top side, and like the pads on the edge of the package, and the inner ones will be placed on the bottom on some better places for that. I don't know. I'm just trying to say what I'm doing, because obviously when I'm silent, you don't know what I'm doing. D2. Something like this. E9. E9. Is on the top, E9. And F1. Like here, okay. Then we have the bottom side. Components. This is the DQ. So for instance, H9. Or H2, I don't know. I don't know. I don't know where to place it. We need a space for the tracks, so I don't know. Really, I don't know. Here. This one can be here. Okay. H1. Here. I don't know. M8. L8. I don't know. We'll see. Yeah. What do you think? I don't know. I am overwhelmed with this. Yeah. Mainly because I'm doing it for free in my free time, which is an euphemism for the time that I dedicate to my social media activity, and we can see that this will be tough. Okay, so we have these decoupling caps for the MPU. This group is VDD. Okay, no. When the item is locked, I don't want to Selected, okay, doesn't work, never mind. 1G1. One G1 is here. Yeah, inside of the pads. This will be crazy. 1G3. That will handle both 1H2 and 1G3, and 1H4 is this one. 1H4, this one. Yeah, probably something like this. The advantage is that the PCB, the component layout for the MPU is the same, so the memory changed, so the package is different, so maybe the number of components is different still. There are issues. As you can see, the components in the second row must be placed somewhere else, and probably I will rearrange them during the PCB layout, because I have to make some space for the tracks, for the differential pairs, for the normal tracks, and I still don't know. There are some pairs. These pairs on the right, like 3 pairs, 1 pair with the clocks, and the other ones are not in pairs, not routed in pairs, but must have the same length or the similar length to avoid some wave actions, etc. So yeah, let's continue. I'm talking too much again. Okay, this group is VDD CPU to be assigned to this pads. So this group goes to the bottom and goes here. The first one is 1B6. So this is 1B6. 1B6 is here. This one is 1C5. Probably it will be handled by this 1C7. Where is 1C7? One C7, where are you? 1C7 is here. Yeah. Probably this one. 1D6. One D6 is here. Okay, I will place it here, but I am not sure. We will see. And the last one is 1D8. Which is here. Maybe this one. I don't know, we will see. Okay, so we have this capacitor, which is unique to C2. A C2 is at the edge of the package, so it will be this one, most likely. Okay. This one, and we have VDD IO1 with 3 pads and 2 components. And the pads are 14, 12, 8, and 10. So F row 8, 10, 14, 12. Yeah, am I right? 8, 10, 12, 14. Yeah, 4 consecutive even numbers. F8. F8 is here, so this will be this one. This one. This is this one. So F8, 10, 12, and 14. So the fourth one will be probably this one. Where is the... No, the fourth one. Oh, there are only 2 of them. Okay. Okay, so it's not correct. Probably this goes here to handle both 14 and 12. And this one will handle either here or no. Either here or here will handle the 8 and 10. So I will keep it here, but there is a potential to move it here. Okay. We have this capacitor. Okay, this is dedicated only to F12. Okay, I was wrong. The F12 is a standalone cap for F12. F12. Okay, so F12 is here. Okay, so let's get back here as it was. And probably this one will be F. No, this F12. If this is F12, it can be here. And this one F10 and 14. This should be 14. Okay, I will keep it here, but maybe there will be some switch between. The positive is, the fact is that the voltage is the same, so we can even switch the caps because it doesn't harm the circuit. We have another group of 4 caps to be connected to this group of 7 pads. So 4 caps to 7 caps. It means on average, all of them will share 2 pads. And the first one is, oh, my neck hurts. I woke up this morning with a sore, stiff neck. Okay, VDD core 1C1. 1C1, so it's the inner capacitor. Will be on the bottom. 1C1, where are you? 1C1 here. 1C1, so probably this. And if the 1C1 handle both 1C1 and 1C3 pads, and 1C3 is here, the cap goes here. Most likely. Uh, 1D2 can handle 1D2 and 1D4. Okay, so this cap probably can handle 1D2 and 1D4. 1D2 is here, is where? 1D2 is here and here. Okay, so the position here is not probably here. Yeah. Yeah, we'll see. Here is 1G5, which is like single with 1G. So 1G5 will be this one. 1G5 is here. I don't know where to place it. It's like there are extra caps. Maybe I will delete some caps. I don't know. 1H6 and 1H8, which is here and here. So the cap looks like this one. Yeah, probably. Here we have 4 caps for 4 pads. Looks like not a big deal, but it will be, believe me. The first one, H16. It looks like the edge, but probably won't. H16. H16 is here. Yeah, so this will be this one. Interesting that the courtyard. Yeah, no. Yeah, okay. Yes. Yeah. I will need to make a short break, but I will do this group. K16. K16 is the same row. K16 is here. There is no cap. But there is M16 as well. Okay, I will place it here. We will see. M16. M16 is here, yeah, so it looks like this cap is this cap. Yeah, it's a mess, but you can see there is not much I can do against it or to solve it. Yeah, it seems that the pads are so close together that one cap can handle both of them, but yeah, it's barely the truth. Okay, we have these two components for W19. W19. I hope it will be at the edge of the package. What's the pad? W19. W19 is here. So it's resistor and the capacitor. Why is it connected this way? Yeah, exactly. The cap must be closer to the pad and the 0 ohm resistor is here. This is not correct. This is, yeah. The extra capacitor here, or not extra, this one, but here, placed here, would create an additional impedance for this track, which we need the like low impedance, low inductance track, not with some components inside. So this cap will go here to W19. Probably can be this one. And this resistor can go here. Yeah, maybe. Okay, let me take a short break. Yeah, you know me. I am a fan of KiCad, but sometimes I am not a big friend of it, or vice versa, I don't know. The fact is that I am working on some courses and I created 2 of them. One is KiCad for beginners and the second one is KiCad for makers. I am pretty sure you can learn something even from the beginners. 2 days ago I received lovely feedback that even a skilled PCB designer who starts or who has started working with KiCad wrote a message to me that he learned something even he's not a beginner. So yeah, it was lovely. The fact is that KiCad for beginners was designed for beginners. You can learn symbols, footprints, creation of both, assigning 3D models, obviously schematic capture, PCB layout, component placement, manufacturing data export, everything connected with the PCB manufacturing. And there is a special promotion. Here is the cooperation with Next PCB company. If you enroll the course, you will receive a coupon within 30 days from the date of when you paid for the course, and you can redeem the coupon at nextpcb.com, and you will receive the entire assembly for free, not just per PCB, the PCB with the components. The same is valid for KiCad for makers. You will design this or similar boards. There is a board with the dual core RP2350, I'm sorry, dual core MCU from the Raspberry Pi. There are 2 buck converters, M2 connector, 4 analog inputs, analog power outputs, 2 USB-Cs. Yeah, as you can see, the same is valid here. You will receive your board for free if you redeem the coupon that you would receive within 30 days after the payment of the course. And the average I calculated I don't know, 2 months ago. The cost of the PCB plus components is about $100 in this case. And if you can see here, the lowest price for this course is €69, which is like 75 US dollars. So if you enroll this course for $75, you will learn, I hope, and I'm pretty sure you will, learn a lot. And then you will receive the board, which has a value of 100 maybe plus US dollars. So I don't know, it's a no-brainer to me, but you will see. In this case, obviously the board is less expensive, but as well the course is less expensive, so it's up to you. Let me take a short break and I will be here in a minute. Thank you. Thank you for your patience. I'm back. So yeah, KiCad for beginners, KiCad for makers at fedewell.com, and we can get back to our decoupling capacitors. So V19 we placed this combination. Now we have these 2 caps. and the target pad is W6. So should be easier to assign W6, but yeah, nothing is as easy as it looks like. W6, which is here. W6 is here, and here is some space to fan out the components. So I think I will place it on the top side. I don't know, maybe here. We will see. Here is other one, L1, a single one for L1. L1 is definitely an edge row, which determines the position to be here. Other one is here, D2. D2 is not edge, but near the edge, so I will place it on the top side as well. D2 is here and can be this one. Don't know for sure, but I will keep it here. The other one is this one, and this one should go to V18, which is near the edge as well, V18. V18 is here. It's not a V19. And this one I'm working on right now is V18. Yeah. Yeah, I can see. I have to update the PCB. Yes. Yeah, I was confused why there is the VCC VDD 3.3 USB where there is the resistor in the line, but yeah, the PCB layout wasn't updated. So F16 is this one. F16. It's like the fighter jet. F16. F16. F16 is here. Okay. F16 is here and should be this capacitor. Yeah. For the card layout reasons, as you can see. Oh, I can't place it exactly at the spot, but I will consider customizing the card layouts to allow a tighter placement. But it's not crucial right now. F16 is placed. Is it? Yes. And the last one on this side is D16 and R17. D16 and R17. So let's D16, the row 16 is here, and R17, yes. R17 is here, and D16 is... Obviously, this won't be handled by only one capacitor. The D16 pad is here, and it should be handled by other one. Yeah. Yeah, it will be a puzzle. Okay, what is the other side? A bunch of grounds. Then there is this group which has C17, should be close to M8, M6. So this entire group, including this entire group should be placed somewhere, but the most sensitive spot is this capacitor connected with M6. So M6 is this one. I don't know, maybe this one. I will change it to 2.0201 because there is a bunch of them, and as you can see, it's a big one. Yes. So update PCB to make the footprint lower, smaller. Yeah, I will place it here, and as you know, we will see this will go definitely what's on the top side? Nothing, maybe tracks only. I will place it on the top because yeah, and onto the bottom. Okay. Oh, okay. I will not try to be hero here because obviously it's not needed. There will be a lot of opportunities to show some PCB layout muscle and component layout muscle. Yes, this is it, and the header will be on top. I don't know, maybe here. Oh. Yeah, the original layout, I'll place it somewhere as I did. This is this group of two caps, Y8. So Y8 is where? Row number 8 is here and Y is here. Okay, so it looks like this one. and this one. Probably. And the last one in this sheet is H6 capacitor. Row number 6 is here and H is here and the empty spot is here. Okay. Okay, we are 100, I'm confused with the numbers. 1 hour and about 45 minutes in the show. And probably I won't start another sheet because it would only bring some confuseness into my already confused head. So I will continue with these components next time, which is the rest of the MPU components, and then with the other ones. So yeah, obviously you can see at the first sight, not much work has been done. Can be truth, but it's not a easy job. You know, what I can do is to sort a few groups because it will help with the organization of the components. The JTAG connectors with the diodes. There are a lot of components extra because, as you can, if you can remember, I added all the ESD protection diodes because the reference design was free of the ESD diodes on the connectors, not only connectors. The designers was reluctant with them. I don't know why. Okay, crystals and some components connected to the pads directly. Test points, yeah. Some tune capacitors, resistors. So yeah, this group, which is, I don't know what. Yeah. So this will be done next time. And the PMIC is here, which will be a big group. This is the buck converter. And the rest is the PMIC. Yes, PMIC. And what's this? The ground. Yeah, always needed. And sometimes we forget to place the ground spot, and then we have measurement issues because the ground is somewhere on the other side of the board, on the other edge of the board, shortly on a incorrect spot. SD card, yeah, it looks simple. Peripherals, yeah. M2, yeah, it will be rather easy. And as you can see, as I identified at the beginning, they placed the components for the M2 on the bottom side, but I'm not a friend of it. I will try to place it on top because we saved a lot of components for display, and I think just two groups for MPU and the memory is enough for the bottom side. DDR is already done, and the Ethernet, which is here, is not a big deal as well. Okay, it looks good. It looks good. I think, yeah, really the big deal will be this core, and I will probably work on the PCB layout before I place all the other components, because as you can see here, no, the spot is rather empty. So for obvious reasons, there are a lot of tracks here. Yeah, we can check it here. I don't know what is the top. I think no, this is the silk screen. This is mask. This is the top side. Yeah, this is the top side. This is memory. This is MPU, and you can see there is a bunch of tracks. Yeah, these are the pairs. These are the single-ended tracks, and I think this is the bottom side. Yes, so one pair is here, bottom side, and some other ones are here. Yeah, we won't need this GPIO connector, so a lot of tracks won't be there, which is really good. This is the power layer, and this is no, this is top side, this is mask, this is the layer 2. Where is it? G3. Okay, G1. Yeah, this is the G1, which is the layer below the top, which is the reference plane, and here is the layer near the bottom side, like above the bottom side, which is power/ground, and I would like to dedicate this layer as ground and add two more, like to transform the PCB to 6 layers, because it will bring some quality to the PCB layout, plus it will not affect the price much. As you could see, the price difference is about $20, and if I spend 2 hours more, it is much more than $20. So probably this will be a 6-layer piece. Okay, let me conclude the session today at this spot. Thank you for your support. Thank you for watching. If you want to support me even more, you have a few options. You can click like on the YouTube. You can send me some comment. You can follow me on LinkedIn, which is here is my, or maybe here are some banners. Yeah, here is the address, and here is my profile. Yeah, this is me, as you can see with the headphones. This is me. Yeah, I should shave my face. Okay, so thank you for being here. Thank you for watching. I enjoyed the event again, and see you next week. I will continue with the component placement, and then we will start slowly with the PCB layout for the memory, which is like the motivation of this design, because I wanted to show to the world that KiCad can, even with some pain, can route the tracks for DDR3, 4, or even the more integrated technology memories. Of course, it can. You can do it with your pen and paper, but yeah, it depends on the level of pain in the process, and I hope we will do it smoothly. So thank you again. KiCad for beginners, KiCad for makers. If you want to learn something from me or from experience I took from the work of my customers during the last 9 years. Thank you for being here. Thank you for watching, and see you next week. Bye bye, my friends.